Question 6 is about estimating the mean. So the table gives information about the speeds of 75 cars on a road. 75 cars. There's the table. Work out an estimate for the mean speed. Now the reason it's estimate is because they've given us grouped data. I can't get it accurate because all I know is that 7 cars were travelling at between 30 and 40 kilometres per hour. I do not know whether they were all doing 31 mile per hour. They could have all been doing 35 mile per hour. I just don't know. So what I need to do is make an assumption for the estimate. And the assumption I'm going to make is going to be about the midpoint. And it's the midpoint of S, okay, because it's the midpoint of the speed. So the first thing I'm going to do is find the midpoints. To find a midpoint, remember you add them both together and then divide by 2 to get the middle. So 30 plus 40 is 70 divided by 2 gives me a midpoint of 35. 40 and 50 is 90 divided by 2 is 45. 50 and 60 is 110 divided by 2 is 55. And 60 plus 70 divided by 2 gives me 65. Don't take for granted that they're always just going to go up in tens. Always check, add them, divide by 2. Then I need to find my frequency multiplied by the midpoint, okay, which I've called S in this case. The reason I do that is because I'm saying there were 7 cars travelling at 35 miles per hour. So altogether they had a speed of 7 times by 35, which is 245. Then I do 22 times 45, which would give me 990. Then I do 32 times 55, which would be 1870. And 12 times 65, which would be 780. What I need to do then, in order to calculate an estimate for the mean, is to find my total of the FS column. So I'd add all of those together, and that would give me 3,885. And then I need to find the mean. And now the mean is the total of your FX or FS column divided by your total frequency. So I know my total of my FS column was 3885. I need to divide that by my total frequency, which is the total of this column, 75. And I put that in my calculator and it gives me 51.8. And the speeds are in kilometres per hour, but that's written on the answer line. So my answer is 51.8. With regards to how marks are allocated for this, you get 1 mark for showing that you've multiplied together what you are using to represent the speed by the frequency. So if you forgot about the midpoint, for example, and you did them all like 7 times 30, 22 times 40. So if you used all of the same value, so you used the minimum speed for each one or the maximum speed for each one, you get M1. However, if you've shown that you've used the correct midpoints and you've multiplied the midpoints by the frequency, you get 2 method marks for that. You then get an additional method mark for showing that you've done your total of that column divided by 75, and you get an A1 mark for getting the answer correct. Question 7 is cumulative frequency. So the table shows information about the lengths in seconds of 40 TV ads, and there they are. There were 4 ads that are between 10 and 20 seconds long, 7 ads between 20 and 30, 13 ads between 30 and 40, and so on. Question A asks you to complete the cumulative frequency table for this information. So the difference in these two tables is that the cumulative frequency always goes from 10, whereas the normal frequency table went from all the different times. So for the first one, it's going to be 4, which is given. The next is all the times from 10 to 30. So it's from 10 up to 30. So it's both of those values. So I do 4 plus 7, which is going to give me 11. And then I add on my 13 which will give me 24. Then I add on my 12, which will give me 36. And then I add on the 4, which will give me 40. So they're my cumulative frequencies. Now we need to draw a cumulative frequency graph for this table. Cumulative frequency graph always gets plotted on the highest values. The reason we plot on the highest values is because cumulative frequency is all about values up to your upper bound. So this is all about values up to 20, all values up to 30, all values up to 40. So there are 4 adverts up to 20. So time 20 seconds, and there's 4 of them. 1, 2, 3, 4. I've checked my scale. There's 10 little squares and it goes up to 10. So each little square is worth 1. My next goes up to 30 and there's 11. So 30, 11. Next, 40, 24. 40, 24. Then 50, 36. 50, 36. Then 60 up to 40. 60 to 40. And cumulative frequency graph is a freehand curve. So I'm going to draw my curve in, connecting all the points. Part C wants us to use the graph to find an estimate for the median length of these TV adverts. The median, and the median is the middle of the frequency. So I've got a cumulative frequency up to 40. I find the middle, so that's going to be 20. So I want to find the 20th TV advert, and I want to see how long that was. So I read across from 20, bounce it down, and that gives me 35, 36, 37, 37.5 I get there. My pen's not the most accurate in the world. So I've got 37.5 seconds, but they've given us the values on the line. Okay, so with regards to mark scheme for this, you get 1 mark for filling in the table correctly. You get 2 marks for the cumulative frequency graph. You can ignore any part of the graph outside the range of points. So if you've connected it down here or connected it up here, we're going to ignore those. So we're just looking at this. You don't lose any marks or gain any marks for that. So it's 2 marks for getting that correct and within a 2mm accuracy. For the median, I've got 37.5. The mark scheme allows anything from 36.5 up to 38. So mine's correct. The reason they do that is because different people's graphs will be slightly out. And that's just a 1 marker. Question 8 is about the mean, but slightly different. It's a bit of a reverse mean question. So 23 girls have a mean height of 153 centimetres. 17 boys have a mean height of 165 centimetres. But they want you to work out the mean height of all 40 children. So they've given us the mean height of the girls. They've given us the mean height of the boys. They want the mean height of all of the children. So the first thing I need to do is find out exactly how tall all of the girls are when put together. So the first thing I'm going to do is 23 lots of 153 centimetres, because there's 23 girls all at 153 centimetres when you're looking at the mean. So 23 times 153 is 3,519. Then I want to find the total heights of the boys. So I've got 17 lots of 165, which is going to give me 2,805 centimetres. I'm then going to add them together to find the total height of all pupils. So when I add those together, it gives me 6,324 centimetres. So that's the heights of all children. What I need to do now is divide that by however many children I've got. So I've got 23 girls and 17 boys. When I add those together, it gives me 40 children in total. So I then need to do 6,324 centimetres divided by all 40 of the children, and it is a calculator paper, that's why I'm zooming through this so quickly, and that's going to give me 158.1 centimetres. They've given us the value there. It's a 3-mark question. You get 1 mark for showing that you know how to get the total heights of girls or boys. So you get 1 mark for getting either one of those. You get a 2nd mark for showing that you needed to add them together to get the total heights. And then you get the answer mark for getting the answer correct. I'm wrong here. You don't get the mark just for adding them together. You have to add them together and show that you're dividing it by the 40. But that's the answer mark. Question 9 is a lovely question. It's simply drawing a box plot. So the table gives some information about the weights of 60 babies. Draw a box plot to show this information. So a box plot has a lower value, a highest value, upper quartile, lower quartile, and the median. So I just need to draw each one of those on this, and they've even given me the scale. So I'm going to start with my lowest, which is 2 kilograms. So there's 2 kilograms. So I'm going to plot a line there. There's my lowest value. Then I'll do my highest value, which is 6.5 kilograms. So there's 6, there's 7, that is 6.5. Keeping all of my lines the same length. I'm doing it between these 2 little squares. So there's my lowest and my highest. Then I'm doing my quartile, so 2.8. So 2.5, 6, 7, 8. And 4.2. So there's 4.1, 4.2. And then I'm going to plot my median, which is 3 kilograms. There's 3. So it is called a box plot, which means I do need a box. And the box is always the joining of the upper and lower quartiles. And the median is always inside the box. I then connect the upper and lower values to the ends of the boxes. So there's my box plot. It's a 2-mark question. You get 2 marks if you've got it all correct. You get 1 mark for a box plot with at least 3 pieces of the information correctly plotted. All right, and you have to include the box. You can't just plot all the lines. You have to have the box. Part 2 says there are 60 babies. Work out an estimate, and it's always estimate because we're not dealing with exact values here. Work out an estimate for the number of these babies with a weight greater than 2.8. Now, that seems a little bit, 2.8 seems a little bit of a difficult number. But if you remember correctly, we've got 2.8 here. And 2.8 is actually represented by the lower quartile. So we want to know the babies with a weight greater than 2.8. If you consider that the lower quartile is 25% of all the weights, so anyone below 2.8 is 25%. So that means above 2.8, we've got 75% of all of the people asked. So they're all above 2.8. So in order to work out if there's 60 babies altogether, of which 75% of them are over 2.8, then I can just find 75% of 60. So that's 0.75 times 60 equals 45 babies. So there are 45 babies with a weight greater than 2.8. So you must know what the quartiles stand for. Question 10 is about questionnaires and sampling. Simon is designing a questionnaire for people who visit his sports club. He wants to find out how often people visit his sports club, design a suitable question he can use. Now, for questions, you need a time frame, you need response boxes. So a question he could use is, how often do you visit the sports centre in a week? And I'll have boxes. I need 3 boxes that don't overlap, so 0 times once a week, twice a week, 3 or plus times a week. So that's your 2 marks. Part B. Simon asks 10 of his friends who visit a sports club to do his questionnaire. This may not be a suitable sample. Give one reason why. Well, first of all, he's only asking 10 people, of which they're his friends. And they're visiting the sports club. So obviously, if you don't visit the sports club, you're not going to be asked the question. So there's a number of reasons. The first one I'll give is a small sample. But you can have it biased because it's his friends, and it's biased because it's at the centre. Part C is stratified sampling. So the table gives information about these numbers. There are 365 runners in Simon's sports club. The table gives information about these numbers. Simon surveys the runners in his sports club. He uses a sample of 50 runners stratified by gender and by age. Work out the number of male runners with an age between 30 and 39 years he should have in his sample. So he wants a sample of 50 runners, and we need to know how many of them need to be males aged 30 to 39. So here are the males. Here's the age 30 to 39. So these are the people I'm focusing on at the moment. So there's 45 of them altogether out of a total of 365 runners in the club. So I need to do 45 divided by 365 times by the sample size he wants, which is 50. So in my calculator, do 45 divided by 365 equals whatever, times by 50 is going to give me 6.16, and that goes on to other decimals, but I can't get 0.16 of a person. That'll be really messy, so I'm going to settle with 6 people. Okay, so the answer is 6. It's a 2-mark question. 1 mark for showing your proportional statement and 1 mark for getting the answer correct. Question 11 has the potential to be a complicated question, but it's actually quite simple when you have an understanding of equivalent fractions. So there are n beads in a jar, so that's a number. I don't know, there are a number of beads in a jar. 40 of these beads are black. Julie takes at random a sample of 50 beads from the jar. 5 of them are black. Work out an estimate for the value of n. So let's think of some fractions here because we're dealing with probabilities really. So there's a total of n beads in a jar. 40 of them are black. So black beads, there are 40 out of, we don't know. So 40 out of n. Now we know that when Julie takes at random a sample of 50, so regardless of how many beads were in there, she's gone in and randomly picked out 50 beads. So she's got in front of her now just a collection of 50 beads. 5 of them happen to be black. Work out an estimate for the value of n. Now we can see here the scale factor. If there were 40 beads altogether in the black jar and she managed to pull out 5, then we've divided that by 8. So 40 divided by 5 is 8. That gives us a scale factor. Now I can use that scale factor to go in the opposite direction. So if I divided by 8 that way, I can just times it by 8 to get up here. So 50 times by 8 is 400. So n equals 400. It's a 2-mark question. You get 1 mark for an attempt to compare the fractions. So that's 1 mark there. And then you get the 2nd mark for having the 400.